Using the general form of the generalized binomial theorem previously discussed, let's try to talk about the expansion of this given expression here. This will actually use that generalization because this could be written as 1 minus x and exponent will be negative 2. And our exponent is a negative item. In short, we can use the previously shown or proven identity for 1 over 1 minus x raised to the power of n, which will be equivalent to 1 minus x raised to negative n. Previously, this is its equivalence. We have here, this is actually 1 plus n minus 1 combination 1x plus, you'll have 2 plus n minus 1 combination 2 times x squared. Sorry, there is x squared there, so let me rewrite this one. Minus 1 x squared plus plus until you have here r plus n minus 1 r x to the power of r. So this time, our n here is negative 2. Okay? Sorry, our n is 2 because it's minus n. Okay? So our n is 2. But the exponent is negative n. That's why here negative n. So negative 2, n is equal to 2. So the expansion for this is actually just using this idea. Let me move it down here. That would mean you will have 1 plus 2 minus 1 combination 1 x plus you will have here 2. Your n is 2 minus 1 combination 2 x squared plus, so the next one is if we're going to try x cubed, so our r is 3. So 3 plus 2 minus 1, you will have here combination 3 x cubed plus until you will have, let's try this 4 alone. And of course, you can also try until you have r plus n minus 1 r, or r plus 2, okay, plus 2 minus 1 combination r x to the power of r. Okay, so with that, you can have here, okay, 1 plus, you'll have 2 combination 1 x plus 3 combination 2 x squared plus 3 plus 2 is 5 minus 1, so 4 combination 3x cubed plus until you will have the final form here of r plus 1 combination r x to the power of r. We don't know that yet because the expansion extends infinitely, but we can actually simplify these first portions here. 1 plus, take note that if we have 2 combination 1, that's just equal to 2. Okay, 2 combination 1 is 2x plus 3 combination 2 is actually 3x squared plus 4 combination 3 is actually 4x cubed, and then plus again if you're to reach here r plus 1 r combination r x to the power of r. This is the expansion of this form. Okay, so basically if you have something like that, it's not yet obvious of its expansion, but when you use this form, you use this form with negative exponent, you can use now the generalized form presented previously. Okay, so that's the expansion for 1 over 1 minus x in the square of that. If you are going to ask about this, the sequence, we have 1, 2, 3, 4, and you will reach exceeding order, the increasing order, just like that. Anyway, that is the result for the expansion of this item. Thank you very much for watching.